Well, this is a training program on how to wire up a motor that is dual voltage and three-phase. And by dual voltage, normally we would mean 230 volts plus or minus a few volts, or 460 volts, high and low. And in order to do that, it's really pretty easy if you follow a specific procedure. And we've given you a checklist of steps to follow, and there are 10 steps on this procedure. And if you follow them step by step, it's really quite easy to do, and you should be able to do it without a problem. And this video, though, is going to explain each one of the steps in sequence so that there's no misunderstanding when you go to do it. Well, step number one is to be sure that any source of potential energy, whether it's mechanical or electrical, is isolated and locked out and tagged out. And you need to do this according to your company's policies, and we're not going to discuss that in this training, so you'll need to see other training if you're not sure what to do. But it's extremely important that you be sure that you have no mechanical or electrical exposure to danger when you perform this process, just like it is with any other process you do. Okay, we're going to look at a three-phase motor here. It's high voltage, and this is something we use in our training program. And you'll have a faceplate over where the wires are, and you'll take that off. And what you're going to see are 9 wires that actually go into the housing of the motor. These are the wires that go into all the windings on the motor. And then you're going to see wires that are coming into the motor that supply the power to it. And there will be 3 wires and usually a ground wire. In this particular case, the ground wire is attached back here to the chassis, which you would do. And then there's 3 other wires, and we'll be talking about those in just a moment and how they input into the motor and how you wire these up. And it's all about how do you wire the input wires to the 9 wires that go into the motor, and that's what we're going to talk about. Now, also on this, and this is very important, there will be a faceplate that will have information on it that you will need, and we'll be talking about that as we go through the steps. Okay, this is the faceplate that we're talking about, and you'll notice on it that there are several things. On the middle part, it talks about the volts, and that's particularly what we want to look at. And then a little bit below that, you'll see where it says PH3, that's 3-phase. And on the right, you're going to see the low voltage and the high voltage wiring, which we'll look at in a little more detail in just a moment. Okay, this is a little closer view of the faceplate, and you'll see where it says volts. And in this case, it says 208/230. And so that's the low voltage, and sometimes we call that 240. It'll be in the range of 230. And then /460, and that would be the higher voltage. And so this motor is designed to operate at either the low voltage, which is the range 208 to 230, or the high voltage, which is 460 or close to it. And we'll see that it's wired up differently in those 2 cases, and that's what we're going to be learning in the upcoming video. Okay, now step 3 is going to be to verify how much voltage you're going to be applying to this motor, and that'll depend on, of course, the source of the voltage. One possibility is it'll be the output from a motor drive, especially if you're using a variable speed. Another possibility is it'll be wired directly to your outsource box, a fuse box, if you're making a connection via a contactor. And this would be for a constant speed motor. Now, if you're really not sure what it's going to be, what these input voltages are going to be to the motor, you're going to take a live measurement, which of course means you have to do it with power on, and that would be a subject of another training video. So in any event, you need to decide before you wire it up if you're going to be applying a low voltage, which is in the 230 range for this motor, or a high voltage. And then, of course, in the subsequent steps, we'll learn how to wire it up for these 2 situations. But first you have to learn that. So this will be an example of the output panel for a motor drive controller. This happens to be an Allen Bradley. And it's kind of hard to see, so you'd have to get yourself looking around to where you could see it a little bit better so you could see just what the output was. So here's a better view of that panel, and as you can see by looking at what's highlighted, this is really going to be the 240 volt class. So this is in the low voltage range, and we'll be wiring it up for low voltage. Or maybe you would just be coming out of a fuse box with a contactor switch for a constant speed motor, and so you'd be looking there, and in this example, of course, you'd see that it's basically a 208 volt setup, so that's you'd be going for the low voltage. Now step 4 is just simply telling you that you need to be sure you have the proper size wire nets to make the connections when you make them. And the two things you have to consider when you do that are the voltage rating of the wire net and the size, if it's going to fit on the wires that you're going to be hooking together. And so we won't emphasize that too much in this training. It's pretty much common sense, and we will give you some additional documentation if you need it. But just be sure that your wire nets are of adequate size, but not too large, just that fit just right and have the right voltage rating. Well, now step 5 is to identify the lines that are feeding the electricity, the voltage, into your motor. And there are going to be 3 of them, since this is a 3-phase motor. Now that's really going to depend on your company's color code standards or how the outputs from the source voltage are labeled. And however you do it, you'll end up by labeling 1, 2, 3. Now in this example that we're talking about here, we have a source voltage with these 3 wires here coming in, and I'm not going to worry about the color coding because yours will be different than these, so I don't want you to try to follow exactly what we do here. You need to determine the ratings, the proper labeling based on your company standards. And then you'll notice there'll be a 4th wire that's hooked to the ground of the chassis. But these are the 3 live wires, as it were. They'll be rated L1, L2, and L3. Now, it turns out that if you cannot really determine that, as you'll learn, it's not too important. You could really arbitrarily label these L1, L2, and L3, and then if the motor was going in the wrong direction when you tested it, you would just simply have to switch 2 of them, and then it would reverse direction and go in the right direction. So this is not a real critical thing. It depends really on your company's standards and how you have color coding within your own plant and the labeling, the documentation that's available to you. Step 6 is really where you just connect the ground wire to the motor chassis, which I'd indicated will be done inside the motor. Okay, now we're ready for the fun part. This is where you actually wire the motor up. As we've already talked about, you have 3 input wires labeled L1, L2, and L3, even if you have to label them arbitrarily. And there will be 9 wires now that will be coming out of the motor proper that you're going to be connecting these to. And what's important then is how you hook them all together. So let me first of all make sure we understand these different wires here and how they're labeled. Okay, now as I've already mentioned, you're going to have the input voltage coming from a source, whether it's a motor drive or just from a regular box if it's a constant speed motor, and there'll be 3 wires that'll be labeled L1, L2, and L3 according to your company's standards if you're able to do that. And then there'll be 9 wires coming out of the motor. Now these wires will each have numbers on them. For example, this is the wire number 6, and the way I know it's a 6 is there's a line down below it. The 9 will have a line below it, and then there are 9 of these numbers, and they'll each have their own labeling. There's 8, and here is 3. I'm just looking at them sort of at random. And so you'll see there's 1, and there's 9 of them, and so they'll be labeled 1 through 9. And that's going to let us know then how to hook them up according to the voltage diagram on the side of the motor. Okay, now you go and find the low voltage and the high voltage parts of your labeling on your motor. And in this case, we're going to look at an example of low voltage. If you're going to hook this up as a low voltage motor, you would hook the line coming from the input into the number 2 line of the white wires. And line 1 would go to number 1 of the white wires, and line 3 would go to number 3 of the white wires. But also, according to this diagram, you're going to hook the white 1 also to the white 7 hooked to the L1. So it could be 3 wires hooked together. The input line 1 and line 1 and line 7 on the white wires, and then you're also going to be hooking line 2 to both 2 and 8 of the white wires, line 3 to both 3 and 9 of the white wires, and then you're going to hook wires 4, 5, and 6 to each other, and that's what this wiring diagram tells us to do. So now, just by way of demonstration, I'm going to hook up the first one. I'm going to assume this is line 1 coming from my input voltage. And I fished around and I found line number 1 and I found line number 7. And these are the 3 that all have to be wired together. Line 1 from the input, and line 1 and line 7. And of course you want to always rotate them in a clockwise direction until they're all hooked together. And then you want to take a wire nut of the appropriate size and put on and screw it down good and tight until you now have these 3 wires connected together securely and firmly. And then of course we're going to do that with the other wires as well. And now I've got line 2 and 8 of the white wires, and I'm hooking those to line 2 from the input. And so once again, you just put these 3 together and make sure that they're twisted very well in a clockwise direction. And then you take again an appropriate size wire nut and screw them down. And now we have line 2 from the input voltage hooked to the appropriate wires coming out of the motor. Now I went ahead and did the line number 3 and hooked it to 9 and 3. You'll notice the line below the 9 and to the line 3 from the input. Now those are all 3 hooked up, the 3 inputs are. That leaves me with 4, 5, and 6, the white wires, and according to the wiring diagram, these have to be then connected together. And so these are put together in the same way, clockwise with an appropriate wire nut. In this case, I'm using this red wire nut. And now we have all of the wires. When you get done, all 9 wires are hooked up. And in the case of the low voltage, you have 2 white wires hooked to each one of the input wires, according to the documentation in the low voltage panel here, as you can see. And then the other 3 remaining white wires are hooked together. And now that completes the wiring up of this motor for the low voltage configuration. And we'll talk a little bit more about the high voltage configuration in just a moment. But essentially the wiring now of the motor is done. And then of course the number, step number 7, well actually number 8 is to make sure that all of the connections are secure and to put them all these wires with their connections into the box and to take the plate and put it back on and to secure the plate down. And then you have completed the wiring of this motor in this example for the low voltage configuration. And now I'll remind you that if you were going to wire this motor, in this example with the high voltage configuration, you would look at the wiring diagram, and what you'd see then is that each one of the input voltage wires, 1, 2, and 3, would be hooked to appropriate corresponding white wire, 1, 2, and 3. And then you would hook the white wires 4 and 7 together, the white wires 5 and 8 together, and the white wires 6 and 9 together. So altogether you would have 6 wire nuts required if you count that up. And you'd simply hook them that way, and now you'd have the high voltage configuration wired up, and you'd be good to go. Now, like we said, you're good to go, and so you want to remove your lockout tag out and get ready to fire things up and go. But here's a word of warning. There's always a possibility that you might have inadvertently reversed one of the leads, lead 1 and lead 2 coming in, or lead 2 and lead 3. And so what you ought to do, if you could damage the load by moving the motor in the wrong way, by having it rotate in the wrong direction, then disconnect the load before you fire it up. Otherwise you could do the damage. So that's why we put that in bold, is you want to be sure that you disconnect the load if damage could occur from incorrect direction. And then you want to run the motor very briefly and make sure that it is rotating in the correct direction. Now if it is correct, and if you got the load still connected, then you're completely done and way to go. On the other hand, if it's correct and you had disconnected the load, then you're going to have to reapply your lockout and your tagout procedures, reconnect the load, and then once you've done that, you can remove the lockout and tagout, and really you're done again. If it should turn out that the motor rotated in the wrong direction, then go back and reapply your lockout tagout and go back in and rewire it and simply reverse L1 and L2 coming in. Just exchange the labels or reverse them. And actually you could do that with any 2 of the leads coming in. You could interchange 1 and 3 or 2 and 3. As long as you interchange exactly 2 of them with each other, then you're going to reverse the direction of rotation, and then of course you'll be good to go again. So once you've done that, then remove your lockout tag out and reconnect the load, and you're done. And that is how you hook up the 3-phase motor.